Now let's talk about feedback effects. Knowledge about and modeling feedback effects are also important to any forecasting model. We call this non-recursive modeling in the policy and social sciences. For example, and back to the relation between CO2 and temperature change, it is argued CO2 can have a positive feedback effect. Positive feedback effects are changes to any planetary factor that can create momentum in the temperature increase. For example, if the ice caps shrink in size, it is argued the white cover reduces in size and less heat will be reflected back into space. However, this process can only be in a positive direction because successive increases in heat continue to reduce ice cap size, leading to even less heat reflection and on and on. On the other hand, there are also negative feedback effects as well. Clouds and water vapor, for example, work to reduce temperature. They cool. The issue then is which feedback effects dominate. Do they cancel each other out? Are they local? Are they global? Such questions are central to how we model and forecast temperature changes. These effects are also linked to determining how much temperature change is due to human factors and how much is due to natural factors. Finally, robustness checks. There are numerous ways to ensure actual structural relations and overall model accuracy. One important way is comparing large models, perhaps a few hundred equations, with a very naive model of one equation and one causal variable. Say the prior period value of the variable to be modeled. A noteworthy example in economics is comparing the Klein model to a naive model with one variable. The Klein model earned its author, Lawrence Klein, a Nobel Prize and was widely respected and used for a time. Unfortunately for the proponents of Klein's model, the naive model gave more accurate forecasts. The more general point is the degree of difficulty in finding true structural relations when employing observational designs. And this fact is equally applicable to global warming models and forecasts.